Before I get into this presentation, I want to just give a brief introduction about myself. I have close to 18 years of experience designing all aspects, most aspects of supply chain, and lean is one of my my favorite expertise. So I think it's basically today what I'm going to talk about is some of the lean material handling things we can do in your existing facility or in any projects you might take up in the future. So kind of introduction. So lean, I think the word lean or the practice of lean is in, we know this lean material, lean manufacturing for a very long period of time. So what lean does is basically is trying to eliminate all kinds of waste. So one of the key waste especially in material handling, it is basically transporting or moving the parts from one location to the other location. As you can see from the screen, lean is trying to the definition for lean is basically it's maximizing your customer value while minimizing the waste. Again, the waste can be in any form, but today we'll basically concentrate on the transportation or the moving. So again, there are a lot of things which can happen, especially while storing, moving the materials inside the facility, or in fact outside the facility also. So I'll briefly go through some of the things which we have learned doing several projects, designing the material flow for various manufacturing places, especially your engine assembly, your vehicle assembly, and a combination of a lot of other products. These are the steps which we felt are key for implementing lean in material flow. First is developing a PFAP. PFAP is nothing but plan for every part. I'll go into details in the next slides. Once you have the PFAP, then you start designing your marketplace. Again, your marketplace, location of the marketplace is key, especially in a facility. You always want to be close to the dock and also close to the point of use. But sometimes we understand if it's an existing facility, we have to, you don't have a say, or you cannot have a marketplace where it's in an ideal location. At that time, we need to think about other things we can do. Once you have your marketplace, then you need to start thinking about designing your delivery routes. How do you want to be delivered? What's the frequency? What's the method? Do you want to be delivered through the forklifts, tugger, AGV, or any kind of overhead, overhead conveyor system? So that's the thing. Once you have the marketplace, think about designing delivery routes for delivering the material. So once you have the routes designed, then we need to start thinking about implementing the pull signals. Now, how do you want the routes to be? How do you want the parts to be delivered? Do you want to be on a set time? Every 1 hour or every 30 minutes, you have a route driver going around and checking at the station to see whether they need any parts. Again, that's a non-value added task. Or basically design a system where it's calling into the warehouse for the parts it requires at the assembly or manufacturing line. So these four things are very important, especially for lean material handling: developing the PFAP, building the marketplace, designing your routes, and once you design your routes, how you want the routes signals to be implemented, or how do you want the materials to move from the warehouse to the assembly or to the stations. Developing PFAP. PFAP is literally a foundation for the continuous improvement of material handling system. This is the first step and the very important step for implementing lean material handling. So I recommend for people who are getting into improving their lean process, the material handling process, to get a good grip on the PFAP before they start doing any improvement in the facility. Because we have been burned several times when the customer doesn't have a good PFAP or a wrong PFAP. So what is a PFAP? As a definition, it says plan for every part. So this can be a document, can be in Excel or some kind of a database where all the part numbers are listed. Along with it, you have a description of the part, the daily usage, the container information, how many parts are there in a container, what kind of container they have. They come in, the unit load information, or sometimes, again, it can go, there are a lot of elements you can add on to the PFAP. But if you guys haven't started or don't have a PFAP, I say start with pretty simple things required for a project. Now, part number, name of the part, container density, unit load density, part weight, some of the basic information. And also, once you have this PFAP, it's very important to assign a person for updating this PFAP. You don't want several hands stirring a pot, right? So again, it'll basically get corrupted, inaccurate. So you want one person to maintain the accuracy and also the updating the PFAP. And again, you can set some process guidelines for what's the process for updating or changing the PFAP. It might have to go through the manager, or then the manager decides whether that sometimes the part number changes or any aspect of the data changes. So it's left to the manager or anyone who is responsible for PFAP to make a decision to know whether to include or to change or not to change the PFAP. Again, the last one, again, maintain integrity of PFAP data. Again, this is very important. More accurate you are from the beginning, it will basically reduce repeating the analysis or having this more accurate, a better study when you're using a good PFAP. So once you have a PFAP, then you need to start designing the warehouse. So as you say, as I said earlier, without a good PFAP, you literally cannot design a good warehouse. So again, assuming you have a good PFAP, you can start designing a warehouse based on all the parts you're receiving. And one rule of thumb is the warehouse has to be or should be close to the docks and also close to the point of use. So that's one of the keys. But I know we understand sometimes kind of you're landlocked, some of the assets you cannot move. That in those cases, you do the best you can. And also in the warehouse, there are a lot of other aspects of warehouse or the activities of the warehouse. Now you're bringing in a container, bringing in a unit load. What do? You stage it. You barcode, you scan it, put it into a system, all these kinds of activities. So when you're designing the warehouse, you need to establish what kind of, or you say circle of work, and what kind of activities are supposed to be done in the warehouse. So you collect all the information, what is required, whether those parts require any special handling. Sometimes there might be some fluids that have to be handled in a proper order. So design your warehouse. Again, determine each or the best storage system for each part category. Now, sometimes some parts are very small. You don't want those to be mixed with other bulk parts. Small parts enough. Can you have them on the shelf instead of lying, putting them on the floor? So those are the things you need to establish those guidelines there. Again, each plant have their own set of guidelines. So sometimes it's just common sense. Some of those big parts are basically stored on the floors, or we say floor storage. Some of the small parts or less turnover parts are basically on a rack, so they don't take up a lot of floor space. And also, other very important thing from PFAP you get is establishing the inventory levels for each part number. Now, again, establishing the inventory level depends upon a lot of things. What is the usage, how frequently you're using it, and also where the suppliers. Now, is he local? Is he 100 miles from your location? Or no, is he 1,000 miles from your location? Or is he overseas? Or overseas, no, it can be from China too. For those all overseas parts, you tend to have higher inventory because of variation in the shipment or length of the shipping it takes from source to destination. Other rules, again, it all depends upon the facility. Some of the rules you need in the marketplace. Now, how do you have the parts coming, going out? Do you have a proper FIFO maintained in the system? How do you manage rejected or damaged parts? How do you manage if a pallet breaks down? Those are some of the warehouse operating rules one has to establish. Again, the key thing is identifying all the circle of work involved when unloading a trailer, moving those unit loads from the trailer to the warehouse, and all other secondary activities. Sometimes you might have to remove the banding, remove the lid. How do you dispose them? Where do you dispose them? And who's responsible for all those? You need to basically have a manpower analysis also to be done for all the warehouse activities. again, keep in mind that whenever we're designing a circle of work, we need to make sure that the material handler is not traveling a lot of distance, from dropping a unit load, doing any activities there. So you want to have it as close as possible so that you basically reduce your non-value at a time. That might be your walk time, your traveling time, or any other activities. So once you have designed your warehouse, the next is basically designing your routes. So again, you need to determine, as I mentioned, the best method for delivering the material from the warehouse to the point of use. Again, some of them might be conveyors, forks, tuggers, AGVs. In some of the steel mills, they basically use overhead cranes. So again, your best method based on the product, based on your space, amount of space you have, based on the frequency you have, again, and also the important thing is based on the capital you have. AGVs are great. They require upfront capital, but once you have implemented it, basically set with it. And also other things, after you design, figure out what's the best method. Now you need to determine if you're doing a tugger delivery. You need to make sure what kind of carts you have, and also when you're designing your routes, other things you need to look into is also your travel distance. Again, travel distance according to lean, you need to travel the least amount of distance. So the best sometimes, and also it does happen that some of those aisles might be the highly congested aisles. So you don't want to be waiting or taking more time to pass through an aisle. So again, it depends upon which aisle you need to take, what are the stops, and in certain areas, especially during the breakout rooms or the lunch rooms or cafeteria, where you have a lot of people crisscrossing the aisle. You don't want your tuggers or your forks or your AGVs to be going through those aisles. Again, at the station, you don't want a lot of time loading the station. Sometimes some of those newer systems can be like they call the hands-free system. You basically using a tugger, you basically drive through, and there'll be a exchange of empty containers to a full containers, and you go around with your route. This way, the tugger driver is not getting down, picking a container, walking to the station, dropping it off, picking an empty, walking back to his cart. And those are all kind of non-value at a time. So get to the station from the warehouse as quickly as possible. Spend less time at the station delivering the parts. Again, you need to minimize your overall time delivering the parts. Again, identifying a delivery system, whether you want a coupled system or decoupled system. Coupled system is basically you have one route driver picking his own parts and delivering it to the line, and any other activities with those parts. In a decoupled system, you have one person picking the parts, setting up the cart, and you have other person just delivering the route. In a decoupled system, you can kind of minimize the labor. Again, it depends upon the system. It depends upon the environment or the facility there. In a decoupled system, you have one dedicated person who's just picking the parts for X amount of routes. So you can have one picker picking for several routes. This way, you can maximize the utilization of one person against several other. If someone had to individually pick the routes, sometimes the efficiency might not be that high. Again, as when we design a warehouse, again, we need to create a circle of work. All the activities associated for delivering the parts. Picking a part, decanting, delivering the parts to the station. So all these activities has to be documented properly, and also who's responsible for all this activity. So you guys have to create a standard operating procedure for every route, and also basically identify which parts are going on which route, and try to avoid several routes going through the same area, right? I mean, you don't want, if one route can cater to a specific area in the plan, you don't want 2 or 3 routes going to the same location. So again, conduct material flow analysis. You have Pro Planner, which is a pretty good tool, which kind of what you see on the screen, those you have the Euclidean lines, that straight lines on the top, basically showing your source and the destination. You can see how far you are from the warehouse, or how far you are away from your marketplace to your point of use. And the second chart, which is in the middle, basically showing all your routes through the aisle, and those red ones, what you see is kind of all the congested aisles. Sometimes you can avoid them. Again, it depends upon what kind of congestion you have. Is it just a vehicle congestion, or it's both vehicle and people congestion? Sometimes you need to minimize the vehicle travel on certain aisles based on the people around that aisle. As I mentioned, especially during the breakout areas, your lunchrooms, your restrooms, sometimes we need to avoid there because it's just a safety risk. All right, so once you design your route, the other part is now establishing pull signals. How do you want these routes to be established? It can be just be based on simple cadence. Now, a route delivery every 1 hour, right? That's a pretty simple delivery route. Or you can become more creative and have some Kanban system. What we call, some of them are e-Kanban. So a station makes a request for a certain part, only then you deliver a part. So with the Kanban system, you're not going and wasting your time just scouting around the stations for delivering a part. You go only when it's required. So with the Kanban system, it's easier for, or you can say, you can reduce the non-value added time of frequently going for a route driver just scouting around the assembly line or the point of use. And again, that's not, it's basically non-value added. So you can consolidate some of the route drivers, or you can have few route drivers going to every location of the plant based on the call, or what we call sometimes the taxi system. So you get the request from the assembly line based on the Kanban signal, and you create a list of parts you need to deliver, and you assign a certain route driver to deliver those parts. So in a taxi system, they're not assigned to a particular route, but they are kind of randomly given a route to deliver those parts. One drawback in that is the route drivers have to know all the routes or all the stations where they need to deliver the parts. Whereas when you're having a separate dedicated route, now the route driver has a certain station, and that's basically the same station is going to deliver the parts all the time. But a Kanban system or the taxi system, Kanban system with the taxi system, it tends to reduce the overall manpower required for delivering the parts. Again, for establishing Kanban and also the tax system, IT systems are very much required, and basically the industrial engineers and the planners have to work very closely with the IT system so that they know what kind of request has to be made and when. All right, last but not the least, but again, most important aspect of, again, material handling or any project for that matter for lean, which is not always looked at, is basically the continuous improvement. You don't want to be one and done. So you don't want to just do one project and done and wash your hands away and go off from there. Once you're done with that project, you need to go back again and look into the aspects of it might be your warehouse, it might be your material delivery, and ask the question, what can be done to improve? What can be done to reduce the time it takes to deliver a part to the assembly line? What can be done to reduce the inventory of a certain part? Again, this is a very powerful tool, but most of the time, this is the one which is kind of the most, I say, ignored. Most great companies have this as the main, I don't say weapon, but it's an important tool for them for any aspect of improving things in their facility. Again, the key thing for material flow, material handling is basically to reduce the number of touches unit load a part has to go through before getting assembled. So if you chart, if you map out the number of touches or the way a part flows into the assembly line or to the warehouse, you can map out how many times it touches. From initially from the trailer, you have a forklift driver picking a unit load, putting in the staging. From staging, again, he picks it up, it goes to the warehouse. Again, in the warehouse, you have one more person picking it up. So if you count the number of touches, it easily comes to 6 to 7 or sometimes even 10. So we need to make sure how can we reduce that. And sometimes these parts are traveling all over the plant. So we need to avoid that travel. Again, we need to make, the rule of thumb is to always have a straight line flow from warehouse to assembly line? Can you minimize the number of turns, the distance, or congestion in those routes? So again, you don't want to have a lot of turns in your aisle, in your route, because anytime you're turning, you need to stop at those intersection, pause for a certain amount of time, and then make the turn. So you're wasting valuable time. Again, that's a non-value at a time. So it all depends upon, again, keep an eye on all these things. Now, especially try to have the distance short between your warehouse and your assembly line. And at certain places, try to use some of the gravity to help you out. So you can have a gravity flow conveyor, you can say racks. You can drop it off, and because of it, you can have a slopey kind of racks where it delivers to the line. So you need not have to walk all the way 10 feet or 15 feet to the station. So those are things you can take advantage of, the gravity fed racks. Sometimes you can have some small power driven conveyors also. Again, it depends upon your cost benefit analysis. If the analysis shows, hey, I can invest 10,000 a year and reduce an X amount of time route driver has to walk in a year, with a benefit, then yes, you're all in for that. So again, it depends upon the analysis. Again, the key takeaway from this material handling presentation here is try to minimize the distance a part has to travel inside the facility, right from when you receive at the dock to all the way to assembly line, and sometimes back, especially the empty containers coming back into the warehouse and going out to the trailer again. So kind of you map out all the distance for each. Sometimes it's I don't want to say for each part, but if you look into based on the route, you'll be surprised that they travel a long distance from the time they get in to when they leave the facility.